A warehouse employs 24 workers on first shift, 17 workers on second shift, and 13 workers on third shift. 8 workers are chosen at random to be interviewed about the work environment. Find the probability of choosing 2 second shift workers and 2 third shift workers. For this problem, we're going to use classical probability as the base for our calculations. Classical probability is equal to the number of outcomes in event E over the number of outcomes in the sample space. The first thing we're going to look at is the number of outcomes in our sample space. The total number of workers that we have is 24 plus 17 plus 13, which is equal to 54. And out of these 54 workers, we're going to choose 8. When I'm working these problems, if I can ever come across a phrase where I can say 54 workers, choose 8, I automatically think combinations. And most of the time that is correct. So this time we're going to have 54, choose 8. This can also be written as C with 54 and 8 in parentheses. Let's look at this in our formula. This would be 54 factorial all over 54 minus 8 factorial times 8 factorial. Now we're dealing with some very large numbers here, so this is where you would not necessarily want to do your hand calculations, but rather turn to technology like a scientific calculator. So I have one pulled up on the internet. Here I have a scientific calculator that I found online, and if you do a quick search you'll find several options out there. And what I specifically looked for was a scientific calculator that had the combination and permutation tools. You can see here this is the combination tool and your permutation tool. So what I'm going to do is I'm going to show you how you can use the scientific calculator for both calculations, for both the expression that we had and also using the combination function. So let's look at the expression first. Our expression was 54 factorial divided by, now in the denominator, make sure you include both of those in the parentheses. That way it knows, your scientific calculator will know to do that calculation first. 46 factorial, since that's 54 minus 8, times 8 factorial. In the parentheses, then answer. And that's our answer for that combination. Now let's look at using the combination function. For this particular one, you just click the NCR, then put in your 54, put in a comma, and then your 8. In the parentheses, answer. And you can see that you have the same answer. So let's write down that answer. Okay, so that would be the total number of outcomes in the sample space. Now let's focus on the numerator. So for the numerator, we want to look at the total number of ways of choosing two second shift along with 2 third shift, and that only accounts for 4 of the workers. Therefore, the other 4 workers must come from the first shift. So we need to also look at how to choose 4 first shift. And we're going to use combinations for each of these. So choosing 2 up from the second shift means that we have 17 on the second shift. We're choosing 2. 2 from the third shift means that we have 13. We're choosing 2. And 4 from the first shift means that we have 24, and we're going to choose 4. Now what do we do with these? The fundamental counting principle would tell us to multiply these together. Again, these are very large calculations, so what I would recommend is going back to that scientific calculator And let's enter this into our scientific calculator. Here we are at our calculator, and again I want to emphasize that the reason that I'm suggesting that you use a calculator is just from the enormity of the calculations. If you were to do these calculations by hand, they would be very time consuming and tedious. So this is where a scientific calculator really does come in hand and really is helpful. So the first one is 17, choose 2. And what I'm going to do is I'm going to enter this all in at one time. That way we're dealing with just one number rather than 3 large numbers. The second one is 13, 2. And the third one was 24. We're choosing 4. Okay, we have that number there, so we're going to go back and going to put that in our work. So this calculation right here was... Okay, now taking the 2 numbers that we found, this is how we choose that specific set of 2 second shift workers, 2 third shift workers, 4 fourth shift workers. And remember that the probability is going to be the number of ways we can do that over the total number of outcomes in the sample space. And that was what we first calculated, which was 1040465,790. Plugging that into my calculator, I find approximately 0.108. So the probability of choosing 2 second shift workers and 2 third shift workers is 0.108.